Hi guys, welcome to Science in 5. In this video we're going to talk about calculating the relative formula mass. The relative formula mass of a substance is the mass of one formula unit of that substance. It is measured in atomic mass units, or it can be measured in grams per mole. But since we are introducing this idea, we shall stick to atomic mass units for now. Where are we going to get this formula unit of the substance? Well, we will get that from the chemical formula. Remember, a chemical formula shows us the number and type of atoms in a formula or in a substance. In this case, we can see that H2O, this compound is made up of hydrogen and oxygen. Okay, the chemical symbols tell us that. But there is also important information regarding the composition ratio of the atoms. The subscripts in the formula will tell us how many of each atoms are present in the formula. Next to the hydrogen, I can see there's a little 2. Next to the oxygen, there is no number there. So there must be a 1. We'll assume there's a 1 there. So the little 2 here tells me that water is actually made up of 2 hydrogen atoms and 1 oxygen atom. I can read that from the chemical formula. Once I read the chemical formula of a substance, I must be able to break it down into the constituent atoms. Then I can work out the mass numbers of each of those atoms. Where am I going to get those mass numbers? Well, the good thing is I can get this from the periodic table of elements. I do not have to by heart the mass numbers of all the elements. I can get these from the periodic table. An example is this periodic table given right here. To be able to understand where you get the mass numbers, we first of all have to look at the key that is given in the periodic table. In this periodic table, we can clearly see that the relative atomic mass is the number given at the bottom, whilst the number given at the top is termed the atomic number. Put it this way, you'll notice that for all elements on this table, other than hydrogen, there's always a combination of a big number and a small number. For example, let's look at nitrogen. There's a small number 7 at the top, and there's a big number 14 at the bottom. The small number tells me the atomic number. The big number at the bottom is the mass number. That's the number we're interested in. The electronegativity on the side, well, we're not going to focus on that for now. So being able to read the periodic table is crucial to be able to unlock the skill of calculating a relative formula mass. Okay, so now we can read a periodic table. Let's continue with our calculation. So from the periodic table, the mass of hydrogen is 1. The mass of oxygen is 16. This will give me a total of 18 atomic mass units. Okay, let us proceed quickly to another example. So most chemical formulas that are written in this format are fairly easy to work out because you look at the subscripts and you can easily break down the substance. But some cases you get substances that have got interesting formulas. A case in point is this. This compound is called chromium 3 sulfate. Okay, how am I going to work this out? I just need to find a systematic way of doing it. Okay, I can see here in this formula there are 2 chromium atoms, right? I'm going to need the mass of that. But I've got a combination of atoms in a bracket. I've got SO4 in a bracket, and there's 3 of them. So these are 3 SO4s. In this case, it will be easier to get the mass of 1 SO4. Okay? If I can get the mass of 1 SO4, then I can multiply by 3. Okay. So 1 SO4 will be equal to what? There's 1 sulfur there, 32, plus there are 4 oxygens. So instead of writing 16 plus 16 plus 16 plus 16, there's repeated addition. I can just say 4 times 16 because there are 4 of the oxygen. Okay? Then I do the math. I get 96 AMU. Now I've got 96 for the SO4. And I know there are 2 chromiums. Each chromium is 52 according to the periodic table. Then I add all these masses together. I end up with 392 atomic mass units. So that is how you can work out the relative formula mass of a substance using the periodic table and knowledge of chemical formula. Remember, the subscripts, small numbers, tell you how much of the atoms or the combination of atoms is in the formula. Okay, think you've got it? Here's an activity for you guys to do. Try this activity out, guys. That's how we develop skills. Calculate the relative formula mass of the 3 substances listed below. Number 1, C6H12O6, glucose. Number 2, Fe2O3, iron 3 oxide. Number 3, NH4 in bracket, a little 2, SO4, ammonium sulfate. Use the periodic table given to perform the calculation. When you're done, press play to see the answers that will be provided at the end. At this time, press pause to continue with your calculation. Okay, for number 1, I can see that this formula, there are 6 carbon atoms and there is 12 of the hydrogen and there is 6 of oxygen. The reason why I put the square bracket is to avoid it looking like 60. If I just write 6 and O, it might end up looking like 60 and it might be a little bit confusing. Now, since there are 6 carbon atoms, the mass of 1 carbon atom is 12. Okay, so this will give me 6 times 12 plus, so the total mass of the carbons will be 6 times 12 plus there are 12 hydrogens. Each hydrogen is 1 plus there are 6 oxygens. 6 times 16. Okay? When I've got all these numbers, all I now need to do is to get a calculator and do the math. I'm getting 180 atomic mass units. Okay? Remember, you can do it the long way, where you can add the we can add the individual masses of the carbon. You can add 12 plus 12 plus 12 6 times. You can do that for hydrogen, you can do that for oxygen. But this is now a more shorter way, since we now know that repeated addition is multiplication. Okay? Number 2, there are 2 iron atoms, Fe, and there's 3 of oxygen. Okay? Each iron atom, according to the periodic table there, is 56. Each oxygen we know is 16. And this gives me a total of 160 AMU. atomic mass units. Number 3, a little bit tricky. You have to be careful here, but if you follow those steps, I'm sure you would have figured this out. NH42, or NH4 in bracket little 2, means there's an NH4 and there's another NH4, right? And then there's an SO4. So I will need to work out the mass of one NH4, right? It's 14 nitrogen plus there are 4 hydrogens. So this becomes 14 plus 4. This is 18 AMU, right? And I've also got an SO4. I can work out the mass of one SO4. Sulfur is 32. There are 4 oxygens, okay? So we're going to say 4 times 16, and this gives me 96 AMU. Back to the sum there, the top now. The NH4 is 18. Another NH4 is 18. The SO4 is 96. So all I have to do now is on my calculator, add the 18 plus 18 plus 96. Or I can now say 18 times 2 plus 96. This gives me 132 atomic mass units. Okay guys, thanks for watching. This is how you can calculate relative formula mass quite easily. With this technique, you can calculate the relative formula mass of any substance, provided you've got the chemical formula and you've got a periodic table. And this time you might need a calculator to make the calculation easy. Subscribe to the Science in 5 channel for more videos. We've got tons of videos coming up where we explain it and make it as easy as possible, and you may be able to work your science through. Thanks for watching. Add a comment, add a like. See you next time.